Good morning. This is Dr. Sailaja, working as Associate Professor of Mathematics, MLR Institute of Technology, Hyderabad. Today in this lecture, we are going to study about the single proportion in large samples. So far, we have discussed two types of tests in large samples. Single mean and difference of means. So in single mean and in difference of means, the type of data is mean, variance or standard deviation data is given in the questions. Also, in single mean, only one sample data is given. In difference of means, two samples data will be given. Now, we are studying about the single proportion. So here, in this type, the questions will be asked whether the population proportion, sample proportion and population proportion and number of defective items this type of data will be given in the questions. So here in this test, we are going to test whether the population proportion is claimed and whether we have to accept that population proportion is to be accepted or rejected by considering the sample data. So here we calculate a Z test and this is a calculated value. Small p is a sample proportion, capital P is population proportion and Q equal to 1 minus P. If we take population proportion, Q equal to 1 minus P. If we take sample proportion small p, then small q equal to 1 minus P. Since the total probability P plus Q equal to 1. So from this formula, we take small q or capital Q from small sample proportion or population proportion. And here small p, that is standard error of sample proportion, is denoted by standard error of sample proportion is denoted by SE of P and which is defined as under root PQ by N. Here in this test, we define the null hypothesis is what is the claim about the population proportion. What he claimed, that is null hypothesis. So null hypothesis is H0, which is denoted by H0, population proportion equal to P0. P0 is a fixed value or his claim about the population proportion. And alternative hypothesis, previously we discussed it can be defined in three ways, that is H1 is either P greater than P0 or P less than P0 or P not equal to P0. Either of these cases we can define alternative hypothesis and which is denoted by H1. So these two are one-tailed test and this is two-tailed test. So depending on level of significance alpha and Alternative hypothesis H1, we take the tabular value and we compare the calculated value and the tabular value to decide whether to accept or reject the null hypothesis about the population proportion. So here, capital E is the maximum error in our estimation, that is Z alpha by 2 into under root PQ by N. This under root PQ by N is a standard error of a sample proportion, and Z alpha by 2 is a tabular value of Z. And confidence interval for population proportion belongs to small p minus e, comma, small p plus e, where small p is sample proportion and capital E is maximum error of our estimation in population proportion. So small p minus e is lower limit and small p plus e is upper limit. So population proportion belongs in this interval small p minus e and small p plus e. So these are the tabular values of Z according to their level of significance. If level of significance is 10% or 5% or 1%. If it is two-tailed, that is not equal. If it is right-tailed, greater than. And if it is left-tailed, less than. Depending on this type of test and the level of significance, we take the tabular value of Z. Now we see the examples based on the single proportion. So single proportion means we take only one sample data and we define the null hypothesis H0 as his claim in the question whatever it is given about the population parameter. A sample of 1000 people. In Karnataka, 540 are rice eaters and the rest are wheat eaters. Can we assume that both rice and wheat are equally popular in this state or 1% level of significance? So this is the data given here. So here in Karnataka state they have taken the sample as 1000 people. So here the sample size is denoted by N, which is equal to 1000 and which is greater than 30. So that's why this is large sample. And moreover, what type of data is given? Out of 1000 people, 540 are rice eaters and the rest are remaining are wheat eaters. So two types of rice eaters and wheat eaters are given. Rice eaters and wheat eaters are given. So the rice eaters are 540 and the rest are wheat eaters, that is 460. 460 are wheat eaters, 540 are rice eaters. So here what we have to test? Can we assume that the both rice and wheat eaters are equally popular? So both are same ratio. They are in the same ratio or not. So that's why we take or we define the null hypothesis H0 is rice eaters and wheat eaters are same proportion in Karnataka state. That is null hypothesis H0 is capital P equal to 1 by 2. Since here capital P is rice eaters are 50% and wheat eaters are 50%. So that's why P equal to 1 by 2 is the null hypothesis H0. That is his claim. Now whether to accept or reject this claim, now we study about the given sample data. So n is equal to 1000 and rice heaters are 540. So what is the sample proportion small p? Small p equal to x by n. Here x is number of rice heaters and n is total sample size. So rice heaters are 540 and sample size is 1000. So this value is sample proportion. Out of 1000 people in Karnataka, 540 are rice eaters, means what is the proportion of rice eaters in that sample. So here 540 by 1000 is sample proportion and which is denoted by small p, which is equal to 0.54. And we know that total probability is equal to 1. If p equal to 0.54, then q equal to 1 minus p. That is 1 minus 0.54. Now we define the null hypothesis, that is both rice and wheat eaters are equally popular or equally proportionated. So that's why H0 is P equal to 1 by 2. And alternative hypothesis we can define in any case of 3 ways. That is H1 is P not equal to 1 by 2. That is two-tail test. Not equal means two-tail test. This is alternative hypothesis. And level of significance, that is already given in the question, 1% level of significance. So at 1% level of significance, alternative hypothesis is P not equal to 1 by 2. Now the test statistic, here everything, that is the data is given in a proportion and moreover one sample data is given. That's why we apply in large samples Z test, and proportional test statistic is small p minus capital P by under root PQ by N. So here 0.54 is sample proportion, that already we calculated. Sample proportion small p equal to 0.54 and capital P is our claim. Both rice and wheat eaters are equally popular or equally proportionated. So that's why capital P equal to 1 by 2. 1 by 2 is 0.5 by under root PQ by N. Here P equal to 1 by 2. Rice eaters are 50% and wheat eaters also 50%, that is his claim. So that's why capital Q equal to 1 minus P, that is also 1 by 2. So PQ by N, where N is size of the sample. So after simplification, we get Z calculated is 2.53. Therefore, Z calculated is 2.53. At 1% level of significance for two-tail test, at 1% level of significance, two-tail test, 1% level of significance, Z tabular value is 2.58. So this is the tabular value. Now we consider the tabular value is 2.58. So Z tabular value is 2.58. Now compare calculated value with the tabular value. So Z calculated is less than Z tabular value. This is 2.53 and tabular value is 2.58. So that's why Z calculated is less than Z tabular value. Whenever calculated value is less than tabular value, then we accept null hypothesis at 1% level of significance. Therefore, we accept null hypothesis H0 at 1% level of significance. So this 1% level of significance means that 1% may be error in our claim. or in our estimation about the population parameter, that is capital P equal to 1 by 2. Now see the next example. A manufacturer claims that only 4% of his product are defective and a random sample of 500 were taken, among in which 100 are defective. Test the hypothesis at 0.05 level. So what is the data given? First, always we write the data in mathematical notation. That is the first step. So what is the size of the sample? So here n is equal to, size of the sample is denoted by n, and a sample of 500. So that sample contains 500 articles. So n is equal to 500. That means only one sample is taken. So that sample size is 500. N is equal to 500, which is obviously greater than 30, means large sample. So here we consider this problem as a large sample problem, and moreover what type of data it is given. Now we observe here x is equal to 100. So out of 500 articles, 100 articles are defective. So that 100 articles, defective items or defective articles are denoted by number of defective articles denoted by x. So x value is 100, where x is number of defective articles. So x is 100, sample size is 500. Now we can calculate the sample proportion small p equal to x by n. This is the formula to calculate the sample proportion. If sample size and number of defective articles out of that sample is known, then we can calculate sample proportion by taking the formula x by n. So p equal to x by n. X is 100, n is 500. So small p equal to 1 by 2. And what he claimed, a manufacturer claimed that only 4% of his product, overall manufacturing product, only 4% is a defective product. So that is his claim. So 4% means 0.04. So here the population proportion is denoted by capital P, and which is claimed as 4%. Only 4% of total product is defective in his factory. So that's why capital P equal to 4%, which is 0.04, and we know that total probability is equal to 1. So capital P plus Q equal to 1. If P equal to 0.04, then Q equal to 0.96, 1 minus P. Q equal to 1 minus P. So Q equal to 0.96. We know the values capital P, that is population proportion, small p, and that is sample proportion 0.2. So this is all about the proportion data and one sample data. Moreover, that sample size is greater than 30, that's why that is a large sample. So in large sample, proportion data and one sample data is given. So that's why we apply single proportion. Single proportion. Now see the null hypothesis. P equal to 4%, that is 0.04. And alternative hypothesis, we can define it as in any one of the cases, either two-tailed or one-tailed. So here we have defined alternative hypothesis P is greater than 4%. Greater than means one-tail test. So 4% means P is greater than 0.04. That means there will be more than 4% defective articles in that factory. That is alternative hypothesis if we reject null hypothesis. Level of significance, that is given 0.05 level. So level of significance means in our estimation about the population parameter, there may be error. That error we have taken it as 5%. So that is 0.05 and it is denoted by alpha. So alpha equal to 5%, and here we applied Z test since single proportion. So Z is equal to small p minus capital P by under root PQ by N, or standard error of sample proportion under root PQ by N. Now small p equal to 0.2. After calculation of sample proportion X by N, we got 0.2. This is sample proportion, and capital P is our claim, that is 0.04, and under root PQ by N, that is 0.04 and 0.96. Q equal to 1 minus P by N equal to sample size 500. So after simplification, we got calculated value is 18.26. Even though we get a calculated value in negative, we take always modulus of Z calculated. Remember this point. So here Z calculated value is 18.26 and Z tabular value. So at a 5% level of significance for right tail test, this is greater than. In greater than means right tail test. So see here in tabular values, at a 5% level of significance for right tailed, tabular value is Z alpha equal to 1.645. So here calculated value is 18.26, tabular value is 1.645. So compare calculated value with the tabular value, then Z calculated is greater than Z tabular value. If calculated value is greater than tabular value, then we reject null hypothesis. Therefore, we reject null hypothesis H naught at a 5% level of significance. At a 5% level of significance, we have rejected null hypothesis means obviously we are accepting a alternative hypothesis. What is alternative hypothesis? There may be greater than 4% defective articles in that factory. Another example, a die was thrown 9,000 times and of these 3,220 yielded 3 or 4. Is this consistent with the hypothesis that the die was unbiased? So he is claiming that whether the die is unbiased. So unbiased means we know that how to calculate the probability of when throwing a die, probability of X equal to getting 3. When throwing a die, what is the probability of getting 3 is 1 by 6. Out of 6 possible outcomes, getting 3 is 1 by 6. Similarly, 3 or 4. So that is probability of getting 4 is also 1 by 6. Since we are considering or we are claiming that the die is unbiased. Unbiased means we take equal probabilities for all possible outcomes in a random experiment. So that's why probability of getting 3 is 1 by 6. Probability of getting 4 is also 1 by 6. But here he has taken that getting 3 or 4. 3 or 4 means we add these probabilities, that is 2 by 6, which is equal to 2 by 6, which is equal to 1 by 3. So what is the probability of 3 or 4 is 1 by 3. That is his claim. Since his claim is the die is unbiased. So that's why capital P equal to 1 by 3, that is null hypothesis. Now what is a sample proportion? So this experiment is done 9,000 times. 9,000 times means that is a sample size. So N equal to 9,000. If out of 9,000 times, 3,220 times yielded 3 or 4. This he has observed. X value is 3220 times occurred 3 or 4. So what is the sample proportion? Number of times 3 or 4 occurred, that is X value 3220 out of 9000, that is N value. Then sample proportion small p equal to 0.358. And here capital P, that is population proportion, is 1 by 3 and Q equal to 1 minus P. Q equal to 1 minus P. So that is 1 minus 1 by 3, which is equal to 2 by 3. So capital P is 1 by 3, capital Q is 2 by 3. Sample proportion is 0.358. So here only one sample data is given, and moreover large sample and proportional data is given. Sample proportion, population proportion, this type of data is given. So that's why we apply in large samples proportional test. So that is Z is equal to small p minus capital P by under root PQ by N. So here after calculation, this is a sample proportion and this is population proportion, his claim 1 by 3. And after simplification, calculated value is 4.92 and tabular value at 1% level of significance, that is 2.58. So calculated value is 4.92. Z tabular value is 2.58. Now compare whether we have to accept or reject his claim or null hypothesis. Therefore, Z calculated is greater than Z tabular value. Therefore, we reject null hypothesis. We are rejecting null hypothesis means, what is null hypothesis? The die is unbiased, P equal to 1 by 3. We are rejecting this null hypothesis. That means the die is biased. That is P not equal to 1 by 3. So these are the different examples in single proportion in large samples. Thank you.